Here I am Dr. Ruchi Bala, working as an assistant professor in Department of Physics at DK College, Dumraon. I am going to present on Introduction to Thermal Remote Sensing. So here I discuss the basic ways of energy transfer. What is thermal remote sensing? The importance of emissivity and the various laws involved in thermal remote sensing. And lastly, the applications of thermal remote sensing. So these are the three basic ways of energy transfer. In first figure, we can see that when a pan is heated and we touch the handle of the pan, we can feel the heat directly. So this is the energy transfer by direct contact. This is called conduction process. Next, here we can in the second image we can see that a jar is full of water, and when it is heated from the below, then the water molecules at the lower surface gets heated, moves towards upper side, and the upper molecules comes down, gets again heated. In this process, the motion of the molecules within the jar results in the energy transfer throughout the molecules. That is, the water gets heated up. In this process, this is called convection process. And the third is the radiation process. Here a person standing away from a fire can feel the heat without any contact. So here energy is transferred through electromagnetic radiation. So this process is this radiation process is involved for thermal remote sensing study. So next is thermal remote sensing. So what is thermal remote sensing? Thermal remote sensing is the is a process in which we sense the heat or temperature of a surface from a far distance. So the various Earth surfaces has different property, and so it has different temperatures. So emits different amount of radiations. These radiations reaches the satellite sensor, and the sensor captures all the radiation, and we study those amount of radiation coming to the sensor to get the information of the temperature or heat at the ground surfaces. So in order to convert the energy to the temperature, we need to first study what is a black body. So an ideal black body is something which absorbs all the radiation coming or falling on it. We can construct a practical black body here. As we can see that we can construct a cavity with a small opening at one side. So when some radiation passes through the opening, inner wall here the inner walls are made up of metallic surfaces. So the radiation that comes within. So here this acts as a perfect absorber in this way. Now when we heat the inner walls, consider at some temperature T, then the electrons on the metallic walls gets excited, and then in the de-excitation process, it emits electromagnetic radiation. So that electromagnetic radiation comes out of the opening, and this is considered as a black body radiation. So this system acts as a complete absorber as well as emitter. So the property of a black body is that it is a complete absorber as well as a complete emitter. So now we move to the term emissivity. Now what is emissivity? Emissivity is the ratio of the incoming ratio of the energy emitted from the surface to that of the radiation incoming falling on the surface. So black body, since it is a perfect absorber and a perfect emitter, emissivity is 1. For real objects, not all the energy reaching the surface gets emitted. Some are absorbed too. So its emissivity is less than 1. Stephen-Boltzmann law was introduced where we can convert the energy of the radiation to the temperature. So in this way, the radiation that reaches the sensor can be converted into temperature to determine the temperature of the body at the ground surfaces. So what is Stephen-Boltzmann's law? It is stated as the amount of energy emitted from an object is a function of temperature. So from this equation, we can see that the energy is directly proportional to the fourth power of temperature. Here, sigma is the Stephen-Boltzmann constant. It is a constant value. This equation is applicable for black body, where emissivity is 1. Now, for real objects, we relate it in this manner, where energy is directly proportional to fourth power of temperature of real objects, which is also equal to the product of emissivity, Stephen-Boltzmann constant, and the fourth power of kinetic temperature. Now, kinetic temperature is the temperature of the ideal black body or ideal body, not real. So, when we relate this, we get that the temperature of a real body is always less than the equivalent ideal body. So, in this way, we can calculate the temperature of a black body from the radiation that reaches from the ground surface to the cell. So now there are various applications of thermal remote sensing like surface temperature detection, urban heat island analysis. Now urban heat island are the urban areas which shows temperature higher than the neighboring rural areas. So now urban heat island analysis is also possible through thermal remote sensing, soil moisture estimation, drought monitoring, forest fire detection, volcanic activity monitoring, and also there are further more applications. So here I conclude. Thank you very much.